back to today's Vidyanagar online science class. I'm going to continue our 10th chapter, Gravitation. And in today's class, we are going to discuss about free fall. So which point we are going to discuss in our today's class? Free fall. Okay, so let's begin. Every objects in the universe attract each other. Every object in the universe attracts each other, or Earth is attracting every object towards its center. Earth is attracting or Earth is pulling every object towards its center. That force is gravitational force. So the pulling of Earth or the Earth attracts every object towards its center. That force is gravitational force. Okay, so just you consider a situation in which an object is falling down. An object is falling down. When an object fall down, Earth attracts that object towards its center. Right? So that falling of an object is due to which force? The falling of an object is due to the gravitational force. So while we are throwing an object up, it is coming down, right? So that coming down or that falling of an object is only due to the gravitational force. Is there any other extra force from the sides or anywhere? No, that object is going down only because of the gravitational force. So actually that object is falling freely under the influence of gravitational force. So that object is falling freely due to the influence of gravitational force. So such fall is known as free fall. So what is free fall? The falling of an object due to the gravitational force. If an object falling down due to gravitational force, such falling is known as free fall. The falling of an object, freely falling object. So that freely falling object means, so actually it is falling freely, but indirectly it is not falling freely because Earth is attracting that object towards its center. So if the object falls down due to the gravitational force, such fall is known as free fall. The falling of an object under the influence of gravitational force, that is free fall. Okay, see, when an object falls down, is there any change in direction? No, only one direction, that is coming down. So when an object falls down, there is no change in the direction of object. That object top to bottom coming in the same direction, which means there is no change in the direction when an object falls down. Then what about the case of velocity? Is there any velocity change? Definitely there is velocity change. So when an object falls down, there is no change in the direction, but there is change in the magnitude of velocity. There is no change in the direction, but there is change in the magnitude of velocity. Okay, you may notice that when an object falls down, when it reaches near to the ground, suddenly it falls down, right? So the object coming from the top, when it is near to the earth, when it is nearby the earth, you may notice that object suddenly fall down. Why it is suddenly fall down? That is due to the strong attraction of the earth. When the object approaches towards the earth or when the object near the earth, they experience a greater attractive force, which means when two objects are attracting each other, there you can see if the distance less, if only very less distance between the objects, there is a great attractive force. When we take these objects away from each other, that attractive force goes on decreasing. That is, force is inversely proportional to the square of the distance. Why the force is inversely proportional? Because when the distance increases, attractive force decreases. When the distance decreases, attractive force increases. When the objects are very close to each other, there is a greater attraction. When we move away from each other, the attractive force goes on decreases. Okay, so when the object approaches the earth, there the distance decreases. If the distance decreases means attractive force increases. That's why the object suddenly falls. So when an object falls down nearby the earth, the speed or the velocity of the object increases. Why? Why the speed or velocity of the object increases? That is due to the strong attractive force. When the object is near to the earth strongly attracts that object towards its center. That's why suddenly it falls down. So when it is coming from top, you know, the object slowly comes, right? Why the slowly comes? Because there the distance more. There the distance for, that's why attraction less. So when the objects, you know, coming from the top, there you can see that the distance is high. Distance high means attraction less. So when the distance increases or when the object approaches the earth, you can see there is a change in velocity or there is change in speed. Why that change in velocity? That change in velocity is due to the attractive force. So when the distance increases, attraction increases. When the distance decreases, attraction increases. So the object at the top, there the distance high, so attraction less. So when that object, you know, approaches the earth, there the distance decreases, attractive force increases. And when the object is very near to the earth, there is a strong attraction from the earth. That's why it suddenly falls. So the point you have to understand from this, you know, sentences, there is change in velocity. There is no change in direction, right? Is there any change in direction? Is that object moving this side or this side? No, only it is coming down, because there is only one direction, but there is change in the magnitude of the velocity. Why? Because when the distance decreases, attractive force increases. That's why when the object's very near to the earth, suddenly it falls. So there is change in velocity. What is change in velocity? Change in velocity is acceleration. Change in velocity is acceleration. So here that acceleration is due to what? Gravitational force. So here the acceleration or change in velocity of the object only due to the gravitational force or gravity. Gravitational force or gravity, same. Okay. So here the change in velocity or the acceleration is due to the gravitational force or gravity. That is acceleration due to gravity. Got it? So when the object falls down, there is change in velocity. If there is change in velocity, there is acceleration. So here that acceleration is due to that attraction, no? Right? So here that change in velocity is due to the attraction. Which attraction? Gravitational force. So here the change is due to the gravitational force or change or acceleration is due to gravity. That is acceleration due to gravity. Here the change in velocity or acceleration is due to gravity. That is acceleration due to gravity. So when the object falls down, there is no change in the direction of the object, but there is change in the magnitude of velocity. When the distance decreases, attractive force increases. That's why when the object is very near to the earth, falls suddenly. Okay, which means there is change in velocity. If there is change in velocity, there is acceleration. Here the acceleration is due to gravitational force or gravity. That is acceleration due to gravity. Okay, so change in velocity is due to gravity or acceleration is due to gravity. That is acceleration due to gravity. Okay, so normally which letter we are using for acceleration? It is A, right? So you can use small a for the acceleration, but in case of acceleration due to gravity, you have to use small g. So what is g? Small g is acceleration due to gravity. What is capital G? Capital G is gravitational constant. Capital G is gravitational constant. And small g, acceleration due to gravity. Small g is acceleration due to gravity. Okay. And what is the SI unit of acceleration? Meter per second square. So same SI unit you can use for g. So which symbol you can use for g? Which symbol you can use for acceleration due to gravity? G. And which is the SI unit of acceleration due to gravity? Meter per second square. Okay. So same unit for acceleration and g. Meter per second square. Okay. And you see, you already studied about the force, right? What is force? Force is the product of mass and acceleration. F equal to ma. F equal to ma. This we studied already, right? Force is the product of mass and acceleration. But here the acceleration is acceleration due to gravity, right? So instead of acceleration, you can use G, mg. So here the force is F equal to mg. Why? Because here the acceleration due to gravity is small g. That is F equal to mg. F equal to mg. Okay, F equal to mg. So what is the acceleration due to gravity? Acceleration due to gravity is due to the gravitational force, or acceleration is due to the gravitational force. That is acceleration due to gravity, and its symbol small g, unit meter per second square, and force is the product of mass and acceleration, but here the acceleration is g. So F equal to mg. Okay, so F equal to mg. Now we are going to make an equation for acceleration due to gravity, g. So what is the equation for force? Gravitational force, F equal to g mm by d square. Right, F equal to g mm by d square. But we know F equal to mg. So instead of F, you can write mg. mg equal to g m by d square. We know F equal to g mm by d square and F equal to mg. So what we did, okay, instead of F, you can write mg. So here it is F now. So instead of F, you can write mg. Then next step, cancel this m. So what remains? G equal to g m by d square. G equal to g m by d square. So what is equation for small g? G equal to g m by d square. How we got that? F equal to mg and F equal to g m by d square. So instead of F, you can write mg. So mg equal to g m by d square. Then cancel this m. So remind g equal to g m by d square. G equal to g m by d square. And its SI unit we already discussed. Okay, what is SI unit of g? Meter per second square. Okay, suppose an object is on or near the surface of the earth. Suppose an object, so this is the object, an object on or near the earth. Suppose an object is on or near the earth, and this is the center now. So you can draw a line. Suppose an object is on or near the earth. So this is that object, on or near the earth. Okay, so if an object is on the surface of the earth, okay, you can draw one line like this. So what is this? This is radius. This is radius. So which symbol you can use for the radius? R. You can use R. So what is the equation for G? G equal to G m by d square. G equal to g m by d square. So here the d is, here the distance is radius now. If an object, here as per the figure, an object is near or on the surface of the earth. An object is near or on the surface of the earth. So if you mark an object here, while drawing a line, you will get the radius. So here the distance is radius. So here the distance is radius. So instead of d, you can use r. So how to write the equation? G equal to g m by r square. G m by r square. So write an equation for the acceleration due to gravity if an object is on or near the earth. If the object is on or near the earth, which equation you have to write? G equal to g m by r square. Why? Because there you will get the radius. So instead of distance, you can use radius. So this equation only for this case. And the general equation for the small g, g equal to g m by d square. So what is the equation for the g? G equal to g m by d square. Suppose if they ask you, write an equation or write an expression when an object is on or near the earth. An object is on or near the earth, there you have to write g equal to g m by r square. You have to draw the figure and write this. Okay, so on drawing the point on the surface of the earth, you will get a radius. So instead of distance, you have to write radius. So G equal to Gm by R square. Okay, and you may study it in SS, pole and equator. What is this? This is equator, right? And this is pole, correct now? Equator and poles. Okay, now we are going to find the is there any difference for the value of G at the equator and poles, right? The value of G is greater at the poles than the equator. Why? The value of G is greater at the poles than the equator. That means that value of G is greater at the poles, the highest value for G at the poles and the lowest value for the G at the equator. Why? You may study it in maths, if the value of the denominator is high, there is, decrease in the value here, right? So if here more value, here you will get the less value, right? So in case of this equation, if R more, G will be less. If R more, G will be less, and if R less, G more. If R more, G less, and if R less, G more. Then you tell me where will be more R? In case of equator, R is more, right? R is more in equator. R is more in equator. That means G will be less. And in case of poles, R less, right? If R less, G max, G high. If R less, G high. If the value of R is less, you will get the highest value for G. If value of R is less, you will get the highest value for G. And if the value of R is more, G will be less. In that case, in case of equator, R is high, so G will be less. So the value of G small at the equator. And what about in case of pole? In case of pole, R is less. In case of poles, R is less. If R less, G will be more. Okay, then you tell me why the value of G is highest, more at the poles than the equator. Because in case of poles, the value of R is less. Poles, the value of R is less. So G will be more. And in case of equator, the value of R is high. If value of R is high, G become small. Okay, so why the value of G at maximum at the poles? Because in case of poles, the value of R is less. If value of R less, the value of G will be more. If R less, G more. If R more, G high. So in case of poles, the radius less, so the value of G will be highest. And in case of equator, R is more, the value of R is more, so the value of G less. Okay, so if R more, G less. If R more, G less. Where? Equator. R more, G less. R more, G less in equator. And what about in poles? Poles, R less, G more. Where? Poles. You have to understand this. Why the value of G max more at the poles? Why the value of G is more at the poles? Because in poles, R is less. The value of R is less at the poles, so the value of G will be more. And in case of equator, the value of R is high, the value of R more, so the value of G will be less. That's why the value of G high at the poles than the equator. So the idea you have to understand, if R more, G will be less. And if R less, G will be more. Okay, so in case of equator, the value of R is high, so there the value of G is less. But in case of poles, the value of R less, so the value of G more. R more, G less. R more, G less. Equator. And R less, G more, poles. So don't, change this. So where the value of G is more? The value of G is more at the poles. Why? Because at the poles radius less, the value of radius is less, so the value of G high. And in case of equator, the value of R more, so G is less. That's why the value of G is more at the poles than the equator. Clear? So equation, G equal to Gm by R square. If the object is on the surface or near the earth, you can use this as the radius. So change the D as R. So G equal to Gm by R square. With the help of this, we can find the changes in the G. So earth is not a perfect square, right? Earth is not a perfect square. So this is the equator and poles. In equator, the value of R high, so G will be less. R more, G less, equator. And in case of poles, R less, so G is high. So the value of G is more at the poles than the equator. Okay, now we are going to find out the value of G. For that, look at the board, there are some values. This is the mass of the earth. Mass of the earth equal to 6 into 10 raised to 24 kg, and radius of the earth 6.4 into 10 raised to 6 meter, and G 6.673 into 10 raised to minus 11 Newton meter square per kilogram square. And G equal to Gm by R square. Then substitute the value. G equal to 6.673 into 10 raised to minus 11 into M 6 into 10 raised to 24 by radius 6.4 into 10 raised to 6 whole square. Okay, so here you can substitute the values. On substituting values, okay, you will get the equation like this. And while we solve this calculations, or while we solve this or while we multiply, and after the multiplication, while dividing, you will get the value 9.8. So on calculation you will get, the calculation is not important. Calculation is not important. What you have to do is just substitute the values and write the value like this. So on calculation you will get the value 9.8. So what is the value of G? G equal to 9.8 meter per second. So calculation is not important. So you will get the values like this. Just you substitute in the equation, then you can write 9.8 into 9.8 meter per second square. This value is very important. What is the value of G? G equal to 9.8 meter per second square. G equal to 9.8 meter per second square. So mass of the earth, radius, and G. This is the equation. G equal to Gm by R square. Put the values, and after the calculations you will get 9.8 meter per second. So the value of G equal to 9.8 meter per second square. Okay, so that's all about today's class. We'll meet you soon with new concepts in our next class. Till then, it's bye. Thank you for watching. Have a great day.